that the tick became a little more accurate than it was in the previous clocks. And then the atomic clock came about in 1949, which was even more accurate than the quartz clocks. The National Institute of Standards Technology built the first atomic clock based on ammonia, but they felt that they could still get this clock to have a more accurate time, and then they changed it from ammonia to cesium, because the atom or molecule can only emit or absorb a specific amount of energy. The radiation emitted or absorbed has a regular frequency, and that's what we want in keeping time. We want that regular frequency so that the time stays constant. We want the same amount of seconds between minutes. We don't want it to change in between the minutes. The first cesium atomic clock was built in England and at the National Physical Laboratory with the help of the U.S. Naval Observatory in 1955. Its accuracy has been improved over time to produce the modern clock. And our Navy actually has the most accurate clock in the world. I think it was, they made it accurate to 20 seconds per, it was like 1 second per 20 million years. So that's a big step up from the previous clocks.
And we have time zones. And in the 1840s, the Greenwich Time Standard was established, and it was the first time zone set at the Royal Greenwich Observatory in England, which is located at 0 degrees longitude meridian. And that's where the whole AM and PM kind of started, because it's at the meridian and then post-meridian. And with this, you can also do history, because if you take the globe and you divide it into longitude and latitude, based on this, 15 degrees from 0 degrees, 15 degrees east and west, it's either 1 hour ahead or 1 hour behind.
If you go west, then it's 1 hour less, and if you go east, it's 1 hour more. Like right now, it could be 11:30 Eastern time, but in California, Pacific time, it's 3 time zones over. So Morgan's smiling, because Morgan is. It's 3 hours less. We're going to need a few volunteers to come up one at a time for this smartboard activity. So this smartboard activity could be used in class to review time. So, yeah, it's telling time to 5-minute intervals, and it goes with the, it was up here before, it goes with the 2nd grade standard for working with time and money, region standard. It says, tell and write time from analog and digital clocks to the nearest 5 minutes. So, you'll see why that fits into the standard as we do it.
Who wants to be the volunteer?
I'll volunteer over here.
Okay.
What do we have to do?
Yeah.
You have to match.
Yeah, like when you come here, you hit play. Because I'm not sure if it's working right. But you can do it from here.
Okay.
You hit play. And then match.
Oh, so you have to match each of these times with what's here. Alright.
And also time too.
Oh, geez.
That's a lot.
That's intense. Yay. Yay.
And there's also other activities.
Try another one. Let's see how organized is that.
Can we all wear sashes?
Who's next? Okay.
What are we wearing? What are we doing?
Let's see if you can be carried.
We're both at the time.
Oh,
Oh, these are messed up now.
Yeah, they're supposed to. The first one is easier.
Challenging.
Yeah.
Stop the clock!
And let's keep going. This one fits the standard because the standard set to go up to 5 minutes. But then there's also different ones that you can go back to. But there's 15-minute clocks, there's 1-minute clocks. So there's different ones.
Like enable editing.
Enable editing. Oh.
Well, first you have to press OK.
It's going to restart the PowerPoint, so.
You have to take a yes.
Okay.
So now we're going to do our hands-on activity with you guys. We'll distribute our clock templates and the cubes, and then we'll talk about how you use them.
You want to do the activity too?
No, I'm okay.
Why not? Part of the class, that's it.
Yes. You have less than 5 minutes. So you spend a lot of time on the history, so yeah.
Okay. Yeah, we only have a few minutes left, so we're not going to do the entire activity, but we'll explain it anyway.
Okay.
What you would do here is you could start to skip count with your class, so you can start at 12, and then point to the 1, and it'll be 5, and then point to the 2, which is 10, and then go all around the clock.
Oh.
And then
You can use the count cube to label that too. So as in 12 would be 12 and 0 and then 5. You can use that. Also.
yeah, and
Like 5 if you were on number 1.
well, you would put.
Do one.
This is what we're
Yeah.
going to do. If everyone would take out a green cube,
1.
yeah, and put it on the 12,
Okay.
and then put different colors in between the 12 and the 1 on the lines. And then put another green one on the 1. Then the kids get the concept that it's 5 minutes that have gone by since the hands were on the 12. And then they could do the entire clock like that. And they would understand it in 60 minutes to 1 hour with intervals of 5.
So cool! Another thing you can Another thing you can also do is you can take a crayon
Please listen.
and a colored pencil and use them to say, the shorthand and the longhand, and they can label that on the clock. You can use that, or they can either color it, use one color for the shorthand and one color for the longhand, to also see if they get the concepts of time, the colored time.
I really like this. And then there's also patterns.
And more patterns, you see how everything is integrated. Okay. Next.
Alright, so move on.
Okay, move on.
This is just another idea. Did you want to explain this?
Alright, well, another activity you can do is shadow clocks. This incorporates the history of time, how they measure the shadows. So one thing you can do is you can take your class outside, it's like a fun activity, and have the kids lay down and take chalkboard so they can draw on the chalkboard and have them draw their silhouette. So let's say they're laying down. Since I'm pressed for time, this is how their shadow looks at a specific time of the day. Let's say in the morning. Then you can go outside again and see where their shadow is, and they can trace where they are and see where it goes. If it's that way, and trace the shadow. So then after all, you see how your shadow calculates that.
Cool.
And it's fun. You're integrating art.
And kinesthetic.
I once did this when I was observing, and we had kids lay down on concrete, and then you had like in partners, and then if you just stand up and you could see your shadow